Hey, what's going on? Welcome back to the channel. Today we're diving into something that's not just a certification topic, it is something you'll see in real networks all the time. Spanning Tree Protocol, or STP. If you ever seen a network go down because of a loop, you know how dangerous it can be. STP is how switches protect the network. Now, I'm not just going to explain it with theory, we're doing this with real Cisco switches. I've got 3 switches set up right here in front of me, and we're going to see STP in action step by step. So here's the setup. I have 3 switches, switch 1, 2, and 3. They are all connected in a triangle, which means one has 2 links going into the other. This kind of setup is common in real networks for redundancy, but it also means there's a loop. And if you got a loop in layer 2, things can go really bad really fast. Okay, so quick definition. What is spanning tree protocol? At its core, it is a loop prevention mechanism. It detects redundant path in a layer 2 network and puts one or more ports into a blocking state so that only one loop-free path remains. STP uses something called the bridge ID, which is made up of a priority number and the MAC address of the switch. The switch with the lowest bridge ID becomes the root bridge, and all other switches try to find the best path to the root bridge. Ports can be in different rows like root port, designated port, or block port. But the idea is simple. STP keeps one path open and blocks the rest. Just in case one link fails, then it'll open the backup. Think of it like traffic lights on a 3-way intersection. If everyone goes at once, it's chaos. STP is like the smart traffic light. It decides who gets to go and when. Before we configure anything, let's watch how STP works automatically when we first connect the switches. Right now I have switch 1 connected to switch 2 and switch 1 connected to switch 3, but I haven't yet connected switch 2 to switch 3, which will complete the triangle. So I'm going to go ahead and plug the last cable in, and we're going to watch STP negotiate the topology live. We just plugged it in, and as you can see here, STP starts sending BPDUs. These are bridge protocol data units, basically messages that switches use to figure out the network layout. So at this point, one switch will say, hey, I'm the root bridge, and the others will start calculating the shortest path to reach it. Each switch picks one root port. That's the port with the best path to the root. Then on each segment, one port is selected as the designated port. Notice how the port transitions from listening to learning and finally forwarding, or blocking, depending on the path STP chooses. Now, we're going to run this to check the interface state. This whole process takes about 30 seconds under classic STP. If we had rapid STP enabled, it will be much faster. We'll cover that later. Every switch chooses one root port, the best way to reach the root bridge. Then on each segment, the switch with the best path becomes the designated port. Any extra port goes into blocking mode to stop loops. STP keeps only one loop-free path open, but if a link fails, it can recalculate and use the backup path. That's redundancy done right. Now that we've seen STP work automatically, let's take it a step further and actually configure which switch we want to be the root, so we're not just relying on MAC addresses. Here you can see which switch is currently the root bridge. By default, it is probably the one with the lowest MAC address. Let's say we want switch 1 to always be the root. We'll manually change its priority. $40.96 is lower than the default 32768. So, switch 1 should now be elected the root. If we now run the show spanning tree command again, we should see that switch 1 is the root bridge. So it is a success. Let's test a failover now. Okay, I'm going to unplug one of the active links. Let's say from switch 2 to switch 1 and see how STP responds. You'll see that the port that was blocked before is now unblocking and going through listening, learning, forwarding again. And this is how STP protects your network while still giving you backup paths. Okay, so if you don't want to wait 30 seconds for convergence, you can enable rapid STP instead using this configuration. That will speed things up dramatically, especially in modern networks. This is a full look at spanning tree protocol, from a real-time negotiation demo to hands-on configuration to failover testing using real Cisco switches. Hope this video helped, and here's a quick reminder. Just like in network, life gets better when there's a plan, some structure, and a way to handle chaos before it loops out of control. If you found this helpful, please hit like, drop a comment, and subscribe for more real networking videos. Thanks for watching, and I'll see you in the next one.